Today we want to talk about linear inequalities and systems of inequalities. So a linear inequality is something that is in the form of a line, but not equal. So here, a linear inequality is something that only has powers of 1. So for example, x plus y is greater than 2 would be a linear inequality in 2 variables. X plus 2 is less than or equal to 4 is a linear inequality in 1 variable. We're only going to be interested in linear inequalities in 1 variable for right now. So we're looking at 1 variable linear inequalities. And the reason for that is these are the inequalities that we could graph on a number line. So while 2 variable inequalities could be graphed on a coordinate plane, 1 variable linear inequalities can be graphed on a numbered line. So let's look at solving and graphing an inequality. Here we have the 1 variable linear inequality, negative 3x plus 4 is greater than or equal to 1. We're going to start by solving this inequality. So subtract 4 from both sides. Subtraction has no impact on the inequality sign. So we get negative 3x, these cancel each other out, is greater than or equal to positive 1. Now we need to divide by negative 3. So we'll do that the same way we would an equation, but when you divide by a negative, your sign here flips. So the next sign will be less than or equal to. So these cancel. We get x is less than or equal to negative 1/3. Using a number line, and you can sketch a number line using a ruler, and that's all you need to graph a number line is just a ruler and pencil. What we're going to do to make this easy to graph, we pick the scale on this number line. 1/3 is a fraction. So it would be difficult to graph if we're using a scale where, say, this is 0, this is 1, this is 2, this is 3. We'd have to estimate. But what we could do instead, and we're looking for negative 1/3. So I'm going to say this is 0, and then we go 1, 2, 3. This will be negative 1. 1, 2, 3. That'll be negative 2. 1, 2, 3. This will be negative 3. Same thing in the other direction. 1, 2, 3. So now each of those tick marks represents 1/3. All right. So for our graph, we need a point at negative 1/3. That would be right here. And that's or equal to, so that should be a filled in point. And we're going to take everything that is less than. So that's everything this direction. So just take your ruler and draw a line that's very clearly thicker than the original number line with an arrow. Everything to this direction of our number line, and we fill that in. You want a good solid line. My preference is that it be put over top your original number line. So now we've solved the inequality. That's what we have here. That's solving. And we've graphed the inequality. That's what we have here, a visual form of the solution. So here we have a linear inequality in 2 variables. So here we're moving things up, and this is actually a system of linear inequalities. So we're actually stepping up several levels in difficulty here, but some of the concepts actually carry over quite well. X and y still have powers of 1. There are no quadratic terms. These are linear. We're going to graph the lines and shade above or below. Just like here, we found the point and we shaded to the right or the left. Here we're going to do that by finding the lines. So we'll start by graphing our lines. So I'm going to create a coordinate system. So now we have a coordinate system in place. I'm going to graph my top line. 2x plus 1 would start here. It would go up 2, over 1, up 2, over 1, up 2, over 1. And because it's or equal to right here, that is going to be a solid line. So let's pull out our ruler, because you do want to use a ruler when you're graphing. We connect our points using the ruler and draw a solid line. For now, we'll put away the ruler and we'll look at our second line. This one starts at positive 3 and goes down 1, over 1, down 1, over 1, down 1, over 1, and it continues like that. This one, however, is dotted. So we do need to make an adjustment. Our line should also be dotted. So as we draw this one, we connect our points as neatly as we can, and we draw our dotted line. Put away our ruler for now. And we find that we end up with 4 regions. We have a region up here, one over here, down here, and over here. 4 different parts. So what we're going to do, there's 2 ways we can do the graphing here. The first is we can take a test point. So if we test it and it's true for both, then it will. We know it'll work. I like to start with 0, 0 because it's easy. So let's plug 0, 0 into both the top and the bottom inequality. So 0 is less than or equal to 2 times 0 plus 1. Is 0 less than or equal to 1? Yeah, for sure. So the top inequality checks out. That's this one here. Now let's plug it into this one. Is 0 greater than negative 0 plus 3? Well, 0 is not greater than 3. So that means that this section did not check out. But it does tell us something. We were on the right side of the solid line. This line we need to be below. Where else would we be below this line, but not below this line? And that'd be over here. We're now below this line, but a bit above this line. So let's test a point there. Let's pick 2, 3 right here. I'm going to move our previous test point over. So if we plug in 2, 3, so 3 is less than or equal to 2 times 2 plus 1. 3 is less than or equal to 4 plus 1. Is 3 less than or equal to 5? Absolutely, that checks out for the top equation. For the bottom equation, is 3 greater than negative 2 plus 3? Well, 3 is greater than 1. That checks out. So the region that we want to shade is going to be this region over here. And we will shade that completely. Comes up to, but does not cross that line. That region is our solution. You can check points in the other 2 regions, and you will find if you picked points here or here, that they would not be solutions to this system of inequalities.